Hello everybody, welcome to your extra lesson for this week, virtual lesson. Today is day 43 of our chemistry studies. So another college job, so you might remember I worked at that juice cannery and the calendar factory, and then I got bored working at the shoe recycler. So then I took a summer job as a lumberjack, and that summer I cut down exactly 2,117 trees. I know that it's exactly that amount because every time I cut one down, I kept a log. Just a reminder that your fix-its from your last exam are due next week on Wednesday, so you should be working on that. You did problem set 5A for homework, and so if you have any problems on that, please reach out to me by Schoology or Remind, and I will post a video with a little bit more explanation about those different problems. So today's learning targets are to deal with Maxwell-Boltzmann and kinetic molecular theory. So we started doing that with our POGL yesterday. We'll get a little bit more clear on him today and move forward. So once again, if you have any questions on the rest of the POGL that we didn't get to in class yesterday, go ahead and make sure you send those in to me, as well as anything that you might need more explanation on in the notes, and I'll respond. All right, so let's work these two left sides in your notes. First one says the diagram above shows the distribution of speeds for a sample of N2 at 25 degrees Celsius. Which of the following graphs shows the distribution of speeds for a sample of O2 at 25 degrees Celsius, dashed line? So go ahead, take a minute, answer that one, and then restart the video. All right, so big difference here is between N2, which has a molar mass of about 14, and O2, which has a molar mass of 16. All right, we're dealing with speeds here. So there is, even though they're at the same temperature, they will have different speeds, and smaller molecules will move faster than bigger molecules in terms of molar mass. So if the black line, or the solid line, is for nitrogen, I'm looking for something that is moving more slowly than nitrogen on average, and that gives me the first one here. Because here's where our average speed would be for that. Average speed for nitrogen would be there. Next one is multiple choice. It says the graph above shows the distribution of molecular speeds for 4 different gases at the same temperature. What property of the different gases can correctly be ranked using the information from the graph, and why? Read through it and then come on back. This is a problem that would be a little bit more difficult if it was mixed in with everything else on the AP test, but it should be pretty obvious here. Again, as we talked about Maxwell-Boltzmann, we never talked about density as a factor. We never talked about pressure as a factor. We never talked about volume as a factor. The only thing that makes sense here is that it's the molecular masses. Okay, same temperature. Okay, and so, or same average kinetic energy. Sorry, and by using Ke equals 1/2 mv squared, we note that different molar masses will result in different molecular speeds. In Schoology, you will find the assessment for POGL Maxwell-Boltzmann. I would encourage you to do it without looking at your notes. See where you're at, see how you're understanding things, and that can be submitted directly to Schoology. So that leaves us with the assignments for this lesson. Okay, number 1, summary and question on the Maxwell-Boltzmann notes. 2, the POGL assessment that we just did. 3, problem set 5B, which is a very quick problem set, and the bulk of the work that you need to do for this lesson is watching the video about IMFs. That's it. We'll see you Monday.